well, Damien George, creative MicroPython for the people who are new. He's the guy in a grey hoodie. And he'll be talking about the latest release of MicroPython, which happened just a couple of weeks ago. So, Damien, take it away.
All right, thanks, Matt. Hope you guys are keeping warm in the hackerspace.
Too bad tonight. Yeah.
Not too bad. It was a bit of a long time coming, and missed a few things that we wanted to get in, but a lot of other things were in this release. So these release notes here, which I'll go through just for interest, will explain what was in the release and some of the interesting things maybe you can look out for. So yeah, there was sort of a lot of internal changes, and well, also some features added. One of those kind of internal changes is U module renaming, which is sort of user facing, but in the end, there's no real changes for any user code. Everything should just work the same. But behind the scenes, we've shifted away from modules beginning with a U prefix for things that are derived from CPython modules. So for example, the time module. In CPython, it's called the time module, time, and you have something like time.sleep. And in MicroPython, we had it called utime to indicate that it's sort of MicroPython version of time module. And this U module naming scheme had a very long history from the very start of the project. It sort of had roots in the Unix port, had a socket module that wasn't called socket, and it was sort of socket-like, but not the same API as CPython's normal socket module. So it was sort of inspired by CPython's socket module, but different. And the idea was to keep it sort of lean and minimal, like we try and do with most things in MicroPython. And eventually it was renamed the socket module because it was close enough to CPython that you could basically use it in place of CPython socket module. So it acted enough like the socket module that you could call it socket, but it was called usocket to indicate that it was slightly different, and had sort of the philosophy of being minimal rather than being 100% compatible with CPython. And then that naming scheme and that philosophy and idea and mechanism of modules starting with a U permeated to everything else, and all of the modules that were based on CPython 1, like JSON, BNASCII, async.io, they all started with a U, especially uasync.io. That's probably quite well known by people, is that it was called uasync.io to indicate that it was, again, slightly different from CPython and intended to be for microcontrollers and MicroPython and embedded systems. But this naming scheme sort of got a bit confusing because it's either is compatible with CPython or it's not. And if it is, it could just be called by the CPython name. And if it's not compatible, it should be called by something else. And so after a lot of sort of thinking and discussion and working out what to do, the best path was just to get rid of the U module naming and sort of try and hide it away, or get rid of it. And the modules that are named by a CPython module, like time or async.io, you just import time and you import async.io. And if it's going to be called that, it has to be at least a subset of Python and be compatible with that subset exactly. And that's what we're trying to do. Well, for the most part, async.io is completely a subset. And other modules like BNASCII and random and so on. So the idea is to be strictly compatible, or at least very strictly compatible, not 100%, maybe 95% with CPython, with a module that's named by a CPython module. And for other things like Bluetooth or network, which are our own inventions, then of course they have nothing to do with CPython, and we have complete freedom there. So, internally the uname is gone, although we've retained backwards compatibility. So you could still import, say, utime and it will work. But the recommendation is to change your code so that it just imports time. So in the release notes here, it describes a bit more about this, about what I've said, and there's a discussion you can follow through with this link. And sort of one example there is the new deflate module. Now, we had originally a zlib module, which was for decompression. And we wanted to add compression to this. And adding compression in a compatible CPython way was a bit tricky, because the way CPython does is you need to either compress everything in place in memory, so load everything in memory and compress it in place, and then write it out. Or you can do streaming compression, but the way CPython does streaming compression is not particularly well suited for microcontrollers and systems with really low memory. And also, compression itself is really hard to do with not much memory, because you have to have a very large, like 32 kilobytes of dictionary in order to remember what you're compressing, so that you can do better compression. Because you've got to look back in the history and say, oh, I've seen this string before, and then I can just compress that bit of the stream. And the further look back you have, the more compression you can do. But most microcontrollers don't want to waste 32 kilobytes just to compress something. And often 1 kilobyte is enough to do a very good job of compression. And so supporting that idea of having configurable window size, that wasn't compatible with CPython either. So we can't make a MicroPython compression library that acts like CPython zlib compression and still make it run well on a microcontroller, and in the cases where you want to do compression in a minimal way without many resources. So because of our philosophy with umodule naming being removed, there was no CPython library that we could be compatible with. So we invented a new library called deflate, MicroPython specific deflate module. And the deflate module includes streaming compression and decompression and configurable window size and a few other things that are configurable, like whether it's a gzip or a zlib or a raw stream. And then this MicroPython specific module we can build on top of and actually provide zlib, which is a CPython module, and also gzip, which is another CPython module. We can provide pure Python implementations of those that are implemented on top of the deflate module. So the deflate is sort of the core implementation of compression and decompression, and zlib and gzip, which are CPython compatible libraries, are implemented on top of it. So if you're used to zlib or gzip, then you can use those. But if you want sort of more fine-grained control over compression and decompression, you can use the deflate module. So that's quite a long story there of modules and compatibility with CPython, but that's the direction we're going in, and some of the changes we've made. So I guess one good thing there is there's now compression support in MicroPython. I'm not sure, I don't think it's enabled on everything, but it's there if you need it. So that's that part. The other big change was moving to ESP-IDF5 for the ESP32 port, which is, I think, a good change. So we don't have support for IDF4 anymore, dropped support for that, just IDF5. And it was a bit of work to update the ESP32 port for that, but I think it was definitely worth it. Something got cleaned up, and now that has much better support for the new variants like S2, S3, C3, and moving forward, obviously, any other variants that are supposed to bring out. So that's a good change. Along with that change came changes to the memory layout on ESP32 boards. And we improved, hopefully, the way that memory is allocated on ESP32. And the way, well, the difficulties there, you have to have enough memory for your Python application, but also enough for auxiliary memory for the IDF for things like SSL sockets, which take maybe 20 kilobytes of RAM per SSL socket. And people in the past have found that sometimes you can't do an SSL connection, or you can't do more than one on an ESP32 because it takes a lot of RAM and it's already been used by MicroPython or something. So now we've tried to improve this. The ESP32 port, if you're running a board with an ESP32 of any variant, it'll allocate initially, I think, around 64K of RAM for the heap, MicroPython heap. And then that will grow automatically as you use more memory. So even if you have lots of external SPI RAM, to start with, you only have a 64K heap, which is actually good because garbage collection is quicker. And so it's actually faster. You're not using all your RAM, but if you need to use it, just allocate, and then it will start to use up more and more of the available RAM. If you allocate too much, then it will just give it out a memory error. But also, if you allocate a lot and there's not much left for the IDF, you won't be able to do SSL connections. So you have to balance off how much you actually need and leave enough for the IDF. Hopefully, well, no, we plan in the next release to also have better support for allocating SSL buffers so that you can pre-allocate them with an SSL context, and then you know that you'll always be able to do as many SSL connections as you have allocated buffers for. But yeah, hopefully we have improved the memory allocation, and hopefully in most applications, the improvement is apparent and doesn't lead to strange out of memory errors. So yeah, just keep that in mind when you're using ESP32. There's a few big things. The other big one was Bluetooth BLE support on PicoW. So the PicoW had Wi-Fi, but the Wi-Fi chip on the PicoW also supports Bluetooth, both classic and BLE, and we've enabled the BLE on that. So that was quite a bit of work to connect all the sort of the plumbing through, but it uses BT stack as the Bluetooth stack, and the standard MicroPython Bluetooth module is available and works, and there are examples, and also AIO-BLE, which is an asynchronous Bluetooth sort of library that runs on top of the Bluetooth module and gives you much more convenient ways to use Bluetooth in async IO. And there are examples for AIO-BLE as well in MicroPython lib. So that's really great. You can do Wi-Fi and Bluetooth. It should be able to coexist. You should be able to do both of them at the same time, just like on ESP32. So that's a nice addition there. The other headline thing here, as you can see, is board variants. So the way we've configured boards is now sort of gotten a little bit more fine-grained, and not only can you have a board, but you can also have a variation of the board. So for example, an ESP32 board might have a variation where it has 8 meg of flash or 16 meg of flash. And there's no point in having separate boards for those, because the only way they differ is by the amount of flash, which is a relatively simple difference. So the idea here is you have a board, and then you can have possible variants for it. And we've tried to clean up the boards. The board names are all uppercase now. They went lowercase on some ports. And ports like ESP32, the generic boards were renamed to ESP32 generic, so it doesn't clash with the other boards called generic. So like ESP8266 board was originally called generic, and now it's called ESP8266 _ generic. And they all have variants, like whether or not they have SPI RAM or the size of the flash. So there's been a bit of cleanup there of boards. So yeah, just be aware of that. The downloads page has all the variants and everything there. Should be self-explanatory about what you need for your particular piece of hardware. There's a lot of other sort of minor things. They were the headline things. Importing has been optimized, and it should be a lot faster now, like order of magnitude 10 times faster. When, yeah, importing built-ins doesn't touch the file system as much. Some new f-string specifiers, hopefully speeding up of the garbage collector by tracking a last used block. And yeah, just bits and pieces for all the ports, broadcast. You can read these notes and see exactly what's been changed. Improvements to PWM. Renesas port has new MCU support as well. There's an Arduino board for that. STM32H5 support for the STM32 port, which is a new chip by ST. And also, another thing which probably should have been in the headline, but it didn't fit. There is a LoRa module was merged. The work that Angus did was merged to MicroPython lib. So this supports the Semtech SX126 and SX127 chipsets, as well as STM32WL55, which has sort of a built-in Semtech chip. And this LoRa module has both synchronous and async I/O mode, and it doesn't have LoRa WAN, but it just has sort of basic LoRa transmit and receive, so you can do your own, just send and receive from modules within your own network. LoRa WAN could be a thing we can add on top of that LoRa support eventually, but right now it's just the basic LoRa protocol. I think that's most of the headline things. As I said, you can read these notes. It's just on GitHub if you click on the release. Lots of people have contributed to this release, and they're all listed here. Thank you very much. Also acknowledging where the funding comes from. So to keep MicroPython, running, we get funding in from various places and listed here. Thank you very much to everyone who sponsors on GitHub, and all the companies who donate time and or money in some way. Down here in the release notes is listed all of the individual changes. So if you're interested in a given port, you can scroll down and see for for ESP8266 port, for example, all the things that affect that have changed. This is just generated from the Git log between releases. So yeah, I think that's all I wanted to say. Actually, yet one last thing, sort of to move on to the next release. We've changed the way versioning will work. The releases will still be like 120.0 was this release. The next one will be 121 was this one. The next one will be 122.0, then 123.0, and eventually 2.0.0. But the intermediate releases, like the nightly builds or the previews or the unstable ones, they're going to begin now to be called with a preview, the word preview in them, and the version number will be the upcoming release. So this version we're talking about right now was 121.0. But the version we're on right now, if you build from master or download a nightly, is 122.0 preview. So this is hopefully going to eliminate some confusion about what version you're on. So we're past 121 and we're on to 122, but we're on a preview of that. And there's a discussion here you can look at if you want to see the reasoning and what's going on there. So that's how versions are named from now. Well, if you're downloading nightlies, that is. All right, so that's all from what I had to say. I can take questions if everyone has any.
Blank faces here, I think. Yeah. Covered it all too well. If you count how many lines there are in that release note, Damien?
The lines in this release note?
Yeah.
Well,
There's a lot.
no. I mean, I don't even remember how many commits there were, but writing those release notes, yeah, I go through every commit and work out what's worth talking about and what the things that are breaking changes and so on. So it takes a bit of time, but there was a lot of commits. It was like a 5-month release. So as in there was 5 months of work in the release.
Are you still aiming for a 2-month release for the next one, or?
Yeah, the next one we've got a date on the milestone in GitHub for first week of December, I think. And that's we're gonna this time that's gonna be a hard date where we're gonna release. It doesn't matter what's in and what's not in. Just be like, okay, let's test and release because it needs to be out, I guess, before Christmas because nothing will get done over Christmas. And yeah.
You alluded to MicroPython 2.0. Was that? I know that's something you've been starting to think about. Was that starting to form?
Yeah, there's already a pull request by Jim to introduce a flag behind which we can hide 2.0 features. I guess not hide, but the idea then is to not have a branch for 2.0 or 1.x, but to have everything done on the master branch of the repository, and anything that's going to be in 2.0 will be gated by a macro flag. So you can turn on that flag and then you'll get sort of 2.0 version of MicroPython or the sort of in progress 2.0 version. And then eventually when we're ready to release 2.0, we'll just turn that flag on permanently. The idea there is that it's going to take longer than one release cycle to do everything we want for 2.0. And having a separate branch will be hard to rebase against and so on. And so we'll just try and do it all in one branch with this macro to gate the features. And there'll be some things which are backwards incompatible changes. We'll try and minimize those and we'll document them all, but there are a few little things that we need to change to clean things up. And they're the things that will be gated behind this macro.
It's the point of going to 2.0, right? Is to allow the freedom to do a few breaking changes to clean things up.
Yeah, but we also have to be aware that people don't like having breaking changes. I mean, everyone hates it when, something breaks in their code. And because these days you have so many dependencies on things that is the probability of one of them breaking, the probability of having one that breaks is quite high, even though people try not to break things. Our CI was always failing for some reason or another because the tools change or black updates its formatting or something like that. But yeah, of course there are ways around this problem. But we are aware that we don't want to break too much stuff because then it's just going to be painful to update. But at the same time, we have to have the freedom to do some things to clean things up for all the future users of MicroPython.